Hi, my name is Nathaniel Kennedy Noble. I'm a data science solutions specialist here at SAS. Today I'm going to do a demonstration on how we can provide insight on sentiment by location using tweets like drug abuse, mental health, and other similar topics. So first we have to ask the data a question. What region or province can we make the biggest impact in? What was the results? Oh, we are able to create a bar chart of the negative sentiment grouped by tweet author location. So here we could see that Brantford, Ontario has the highest negative impact. You can prioritize based on the bar heights from high to low. Next, in order to automate this process, reduce the amount of text analytics that needs to be done in the future, you can create predictive models to actually predict the negative sentiment in new tweets. So what we did here is we created two models, and the decision tree happens to be the one that fits better. It has a lower misclassification rate, meaning better predictions. And this is the flow of how this was done. So we started with asking a question, getting the data, prepping the data, visualizing it, running some text analytics, and then combining those two to then do some predictive modeling. I'm going to take you through a quick demonstration of that. So it all starts at our SAS Visual Analytics Hub. We have everything that we need to do all the different elements of the flow in this screen. Basically here we are ensuring that our source data is always safe, and we create copies that we could load directly into memory that enable us to do fast analytics. Our next step is getting the data. So here you see I have a long search item, and basically I'm using all these tags and I'm searching specifically in the lat longitude of Montreal in a radius of 202 kilometers. These are the different results that I get back when I do that. So this is nice, but how do we get that into data form? And how we do that is we actually import the data. We have a link to our Twitter API. And what I want you to see also is that we could go into local data. We have different servers that we could go into. We have Hadoop. So we connect to just about everything. So here's where we take that similar search term that we use in Twitter and put it here. We don't want to import retweets. Testing. So we're going to see how fast we could actually get these results. So it's actually running a query on Twitter. And voila, there we go. That's our output testing. For the sake of time, I've already done a search in Toronto, West Canada, near New Brunswick, near Montreal, and Ottawa. And here's the main table, and I'm appending all these different tables together to create one big table. And then what we could do is we could explore these results directly, and that'll bring us here. So you could actually see all the different locations that were tweeted from high to low. And we could also do a small amount of text analysis. So let's say I want to look at the tweets that contain overdose and what their relevance was. We should actually take a look through all the different documents. And then from this collection of documents, topics are created. Small topics that took each of these terms and said, okay, there's similar things in here, so we're going to group them together. So you could actually change the amount of topics you want to use. You could identify term roles. You could analyze the sentiment, like on the fly. of this particular topic. And this actually rolls out to all the other different topics that are available. Let's take it into SAS contextual analysis. So we do this by creating a project. Have your different tasks that get updated. Concepts will be created, terms will be created, topics like we talked about earlier, and also categories. So one thing we have is predefined concepts. So when you're talking about searching through location, you could actually find, throughout the tweets, highlighted location. So you have Canada, Quebec, Ontario, Toronto. So these are all highlighted for you. In terms of your terms, this is the individual structured data that was found in each of your documents. What happens in text analytics is you go from this goggly gloop of unstructured data to now structured data. So you take out all the small terms that don't mean anything and you start bringing out these different terms. So for instance, RT is retweet in Twitter. We don't really need that in our analysis, so we could actually just drop that term and that will update. And then again, we actually see the topics with their sentiment, which is similar to what we saw earlier in our text analytics. Then another area is categories. So this is where we differentiate from our original text analysis, where you could actually create rules to organize your text. Now we move on to our segment of predictive analytics. Here's a cluster analysis showing the frequency of different color clusters through several measures. The thicker and darker the line, the more value there is to explore that particular cluster. On our left is a decision tree, which is a set of rules used to classify data into categories. We select a desired response, in this case, the sentiment of the tweets, positive, neutral, and negative. We then input several predictors in which the model chooses to keep the most important to best partition the data. In addition, from those different topics that were created, we now have that in a numerical form, where it's a percentage. So we'd actually put that into our predictors and see which ones are important and which ones are not. And then that's going to build a decision tree that will group these different factors together. And let's say I wanted to look at the negative sentiment of a particular group, because it seems to have a high negative sentiment. You can actually create a visualization from this. And that's where we got to what we saw earlier. And we just want to focus on this one. So we're going to include only this selection. And then you'd want to add here your author location, and you want to group that. So that's how quickly you could actually come to that final answer. Logistic regression classifies data by estimating the probability of a response based on one or more predictors. What I want to point out is that you can see there's two assessments that are very similar, and they have the same categories. So these two models can be compared. Even though they have fit summary and leaf statistics that are specific to the models, there's a point where compare and see which one is actually the best model based on negative sentiment. Now this is the final model comparison that was shown earlier with the decision tree best fitting the data and can be used on future tweets to assess sentiment. Thank you so much for watching. That now concludes our demo. Again, we walked you through how we went from question all the way to predictive modeling and how we got our answers. And if there's any questions, please feel free to email me at nathaniel.kennedy@sas.com. Thank you.